Hello and welcome back. The third assumption of the linear regression is normal distribution of error terms. So we know error terms, right? We have y value. We calculated y cap by using the predict method of the model, and then we calculated y minus y cap. That's called as error term, right? If the error values, the column, if it is in normally distributed fashion, that means the data, right? The data is satisfying linear assumption, or in other words, your line is perfectly going through the data. In the data, your line is going through the data perfectly. Okay, when your line is going through the data perfectly, the error terms are going to be normally distributed. Simple example is that if most of the data points are falling on the line, you will have most of the error 0, right? When I say normal distribution, at 0, if most of the errors, the bar height is too high, and then for the negative 1, positive 1 a little less, negative 2 and positive 2 a little, even less, like that, right? It's going to form a bell curve. That means, right, most of the data is falling on the line, a little bit of data is falling out of the line, even little is going a little farther, like that. If the data is like that, the error term is going to be normally distributed, right? So you can use, if the error type is not forming a bell curve, that's a red flag indicating many problems. Maybe there are outliers or leverage points. Outlier means in y value, if you have too big or too small value, you call it as outlier statistically. In business terminology or business point of view, they may be right, but statistically, if the data points are too big or too small, then we call it as outlier. Leverage point is that on the x side, the input variable side, if you have outliers, then we call it as leverage points. If you have too many outliers in the data or too many leverage points in the data, the error term will not form a normal distribution. In other words, if your linear equation is actually not satisfying the data pattern, right, the error term will not form the normal distribution. Okay, all the error terms will not form the normal distribution. To check this, you can use QQ plot or a histogram. Generally, QQ plot is more preferred because it actually shows you the clear picture. In a QQ plot, you will get a line. If your dots are around that line, forming a linear line, then the data is normally distributed. If the dots are forming a bow shape, right, it's actually there is a skewness in the data. Skewness in the sense there may be errors which are falling on the left side or right side, right? And then if it is forming a S shape, there may be kurtosis in the error term. So we can actually understand the normal distribution using a histogram also. If you look at this, right, it is actually forming a kind of bell curve. So if you look at this plot, or maybe this what you call it as the predicted versus observed versus predicted plot, the data is linearly related to the output variable. We can actually understand that. But to understand the other, the what you call it as assumptions, we are actually doing this. Okay. So how to fix it when the error term is not normally distributed? When the data is not having linear relationship with the y variable, it may be forming. The solution there is that you need to apply some transformation, maybe log transformation, x square root, to make the data a little linearly related to the target variable, right? The other thing is, if the input variables, all input variables are normally distributed, generally you get the error term normally distributed. It is not a norm that it is not that you need to convert your input variables to normal distribution to get the error term normally distributed. If they are in normal distribution, if input variables are in normal distribution, the error term will be, there is a chance that the error term will be in normal distribution. It is desired, not the required thing. So that's about the normal distribution of error terms assumption. Thank you.